Hi guys, greetings from Bulgaria. I'm Anton. Um, I just wanted to say a few stuff. As you know, I'm very active on LinkedIn, and recently there was discussion whether in order to be a really good QA, you need to finish university or not. For me personally, I have a degree, and as you can see behind me, I read a lot, and I try to read at least one technical book per month, at least one. However, why I'm mentioning that? Because really, in order to improve in our profession, the best thing to do is to keep track of these video tutorials and blog posts. This is the real deal, right? How to get even better and better. So thank you for joining us today again from our next video of our tutorial. And don't forget to subscribe for the channel. They're really awesome videos each week on the channel. So click subscribe to get notified about these awesome videos. So let's begin. Today, yet another video from our tutorial for xUnit, teaching you how to write Selenium tests for beginners in C#. Lastly, we discussed first what is xUnit, then we set up the project in Visual Studio, installed all of the dependencies. We talked really deep about the different attributes and how you can write your own. Then we walked into how you can write data-driven tests and automate different web technologies. And in the last fifth video, we talked about how you can improve the speed of your tests and how you can run them in parallel. Today, we're going to step forward, and I'm going to teach you how you can run your tests in the cloud, how you can utilize the power of the cloud, how to run across multiple browsers and operating systems. We are going to use the cool product of Lambda test. And then in the next video, we are going to improve even further using many other advanced features like geolocation, responsive testing, visual testing, and others. Many cool stuff. So now, as I said, let's improve our existing code from last time. Just to like a quick reminder, first, we're going to use for cross-browser testing the cloud of Lambda test. You can visit lambdatest.com to be, to create a free account. In a minute, I'm going to show you many of their features, and in the next video, we're going to check more advanced stuff. Just as a quick reminder, our tests are automating this awesome demo application to do MVC, where written in different technologies, you can find a simple to-do application where we are adding different items here. We can check it, and we verify the items count. And now, I want, before showing you how you can run the tests in parallel in the cloud, let's discuss why you need it. First, when you develop your tests locally on your machine, we usually, as in the previous videos, we're starting and working with real browsers, right, on our machine. However, as you know, the more tests you have, usually there are other videos on the channel about Jenkins and other continuous integration systems. Usually, when we have 1,000 tests, we run them nightly or in continuous deployment a couple of times a day, and we use these continuous integration systems. Our tests there are run through built agents on these machines, and this means that we have a couple of options where we execute our tests. Really, it's not a good option, actually, it's an option. You can configure your own machines where you install the proper browsers, and you can use a tool such as Selenium Grid, Selenium Server. You can download it from the official Selenium site, right? This is this solution here. The drawback here, the problem here is that you have to maintain the correct version of the browsers. You need to keep them up to date and all of this infrastructure. Also, in my experience, when I worked with clients that maintain their own infrastructure, the huge drawback there is that they need to, you need to have a really good system administration team and DevOps engineers who know how to optimize the usage. Meaning that if you don't use the machines, you don't need to pay for them. Because in companies that I worked for in the past, they basically just keep these test agent machines running all the time, and this means that they pay a lot of money. However, nowadays it's much more popular basically to use infrastructure on demand, like this cross-browser testing cloud, where you just, basically these guys here will take care of your infrastructure needs. They have different, basically I already have an account, right? And I'm going to show you, this is the dashboard. Basically, the cool thing here is that first, even if you have, in many cases, as you know, we need to verify our applications manually first, because first of all, we're QAs, right? For this thing, you can use this real-time testing feature where you can start, basically, they will create a virtual machines for you with the different operating systems, different resolutions, and all kinds of versions of browsers, right? All of these combinations, which is extremely hard if you need to do it yourself. Also, they have the same capability with this Elki browser, which basically you can verify on different mobile devices, taking screenshots, videos, and all of that. It's I have tried it and installed it. It's really cool. Also, you can, in the next videos, we'll discuss the test log and the visual testing. It's really awesome if you need to do pixel perfect verification of your front-end website or mobile application. However, in this video, we're going to focus our effort how we can run the test in the cloud through code. And also, don't forget, later on, we need to be able to, run these tests in continuous integration. And not only that, when you analyze the tests, you want to be able to submit bug reports immediately or connect them with test cases. They have, you can see how many integrations with charts, and with this is maybe the biggest list of integrations that I have seen in such a cloud. And also here in the issue tracker, you can submit bugs, which is awesome. Now, let's focus on the effort, how we can run our first test in the cloud. Initially, we're going to convert one of the tests that are not running in parallel, just to see the code that it's not too complex. And then we'll see how we can run one data-driven test in the cloud. And later we'll discuss more advanced scenarios, how through xUnit, how you can basically make your own like a framework and integrate more deeply in the xUnit using the fixtures and other stuff that we discussed in our previous video. But let's start with just a simple test. First, don't forget, you can visit the support docs about C#, right? C# with Selenium, they have really awesome documentation about NUnit, MSTest, and everything, and other languages. You can see examples here. Another useful tool that we're going to use is this capability generator. Again, all of these cloud platforms, Lambda Test in particular, basically they created this, they're utilizing under the hood the Selenium grid for you and Appium and everything. And they're using this protocol, the W3C WebDriver protocol to communicating through the Selenium grid. So basically we're using the remote WebDriver. And in order to generate everything that we need, we can use this capabilities generator. As you can see, there are a few options here: Selenium, Appium, and Selenium 4. Let me show you, like right now, when we select Selenium, we can choose the right platform. Right now, since I use Windows 10, I will keep using Windows 10. You can change the resolution. As you can see, when I change it, here the capabilities are generated for me, but this is Java, so I need to click C#. Then I need to configure a browser, and I can choose a different version. As you can see, the version here was changed. So we need all of these capabilities, or basically settings for the grid, so that it knows how to connect to the cloud. Also, one more thing, you can copy it to the clipboard. And we have some special capabilities, like whether we want to run in headless browser, we can choose a particular Selenium version or driver. And in the next video, we're going to talk about geolocation. And here, it's fully okay if your website or application is behind a firewall. You can configure a tunnel. You can enable console logs, network logs, even a time zone, and we can start screenshots on every action and the video recording. Now, since these capabilities are actually for the Selenium 3 version, which is the stable version right now, Selenium 4 is still in beta at the time of recording. However, you can switch to Selenium 4 tab, and as you can see in the new API version, we need, instead of desired capabilities, every particular browser has its own options class: Chrome options, Firefox options, Edge options, and then we have this add additional capability, similar method to the last one, and we need to use that. You can do the same for Appium, by the way. This is not only for web tests, right? So let's see how we can work on our examples. Just to quickly remind you what we did. Here in the first Selenium web tests, by the way, under the description, you will find different resources like articles and the full source code. You have the same resources in the previous video as well, so you can get the source code from there. Until now, we used a NuGet package called WebDriver Manager. This here comes from there. And this WebDriver Manager is responsible for downloading the correct driver and caching it for us. As you know, the driver is, like an invisible process that starts together through this command, new Chrome driver. And our code is communicating through HTTP protocol with the driver, and the driver itself, it's communicating properly with the browser. And with the Selenium grid, the thing that we need first, basically, we're not going to use the Chrome driver, right? But instead, we need to copy the options, right? I already copied them, and I'm going to show you. First, it's not the best practice to hard code your credentials in the code, right? And the best practice, one of the best practices for folding credentials is to keep them in environmental variables. I already copied my username and access key, and I set system environmental variables with administrative access. And through this get environment variable, this comes from .NET Core, I'm reading these variables with these two names, right? One of them is my username, and the other name is the access key. Then again, I'm going to use Chrome for now. This is why we need the Chrome option. the Chrome options class. And then we need to set up the browser version. Let's say that we want browser version 91. And also we need a platform name. Yeah, as I said, in my case, this is Windows 10. You need, after that, to set the username and the access key that we read. Otherwise, you cannot connect to the cloud. We need to set a name of the build. Right now, I just named the build. Basically, the build is something like a name that later on you can filter on it in the cloud. Also, we can set a name for our test. Basically, we can just place here the name of our test, right? And then we have additional capabilities just to show you the different options. We have Selenium version, console, network. Just bear in mind here that we need Boolean. These two are not strings, otherwise they won't work. And then we need to generate the URL to connect to the cloud. Again, the capability generator will do it for you. We need to add a using statement to the remote driver. And as you can see, we formatted through username. This is called string interpolation. Basically, inside these brackets here, we are mentioning the variables, right? And this will, this syntax here will replace this with the correct username and this with the correct access key. This is the proper URL for the Lambda test grid that was generated for us individually. And later on, let's say that we want to maximize our browser to see correctly everything on the video. Now, we can run the test like this. Actually, I can delete this one. Here, I don't need anything else for now. I'm going to rebuild the project. And I can filter by class here in the test explorer. I can say class, then the name of my class, and I can run the test. And let's go back to the cloud. When I click to automation, let's see, is it working? It's running. Let's refresh. As you can see here, the test is running. If we click on it, we can even connect to the machine and visualize what is happening there. As you can see, the test is already working. It has completed for 3 seconds. It's really awesome here because you can filter, you can view previous executions. As you can see, I run a few so that I can test the demo. You can, since we enabled the networking, since similarly to if you press F12, you can see the developer tools and all of the requests that were made. You can filter by the type of the requests. You have complete Selenium walks here if you need to troubleshoot something. And later on, I'm going to show you here the exceptions. If the test fails, you're going to see the problems here. And also, if there is a problem in your test, and if you have enabled some of the bug tracking integrations, you can create directly from here an issue. And however, if the test fails for some reason, let's now, I'm here going to make it fail. As you know, Lambda tests, we need to write a few more lines of code. Lambda tests won't know that actually the test failed. We need to make sure to instruct it. And the way we do that is that right now I'm going to do it, we need a few stuff. First, let's surround now the code with a try-catch clause. And also, I'm going to introduce a new private variable here called private bool and I'm going to call it whether it passed or not. By default, it will be true. And here at the bottom, if there is an exception, and for some reason my test failed, like again, I changed it to fail here. We need to throw the exception, right, in order the test to fail here as well. And we need to instruct if we want to save this exception in Lambda test so that you can attach, for example, to the bug report, we need to send the exception to the Lambda test cloud. You can do that using executing a JavaScript. We can execute JavaScript in WebDriver if you cast the driver to iJavaScript executor interface. And then we need to mention here Lambda exception, and we need to provide a list of strings or problems that occur in our test. In our case, here we have two items in the list, the exception message and the exception stack trace. I want to catch both of them. And in a final statement, finally, this will be executed no matter whether the test passed or failed. I'm going to execute another JavaScript instructing setting the Lambda test status of the test. As you can see here, we're checking whether this is true or false. If this is true, we're going to set the status to passed. If this is false, we're going to instruct the cloud that the test failed. Let's execute this again. And let's navigate again to the cloud. Again, automation. As you can see, new tests, it was updated automatically. Here it is. And I can again fetch the live stream. By the way, the video recordings are uploaded automatically to the cloud, so you can rewatch them later. And yeah, later on, let's wait. It will wait a few seconds until it fails, right? And then we'll be able to see, we should be able to see here the exceptions. I can already show you one of the failed tests. The test will be marked as failed because of the JavaScript that we set in the final clause, right? Here it is. If we go to the assertions, you will see that right now we already have this, the real problem that occurred in our test, and this is because we used the execute script Lambda exceptions. And the whole stack trace is here. You can see the path, right, to my user folder, which is awesome. Again, you can rewatch the whole execution later. The video is saved for you. And if you enable the, again, the integration with the bug tracking, you can create an issue here, which is really, really awesome. Now, let's see what we can do to, I already showed you one test, but this is not enough. Maybe we should look, one of the more, I'm just going to return one of the to-do tests that we did in the previous module in the course. And here again, we are using the theory attributes. And for each of these inline data attributes, we're going to execute the test 20 times, right? Because we have 20 attributes. And we want here to convert these tests to be executed in the cloud. To do so, I'm going to rename this class, and I'm going to say to do tests in cloud. Again, through the process is similar, right? First, in the constructor, this constructor will be executed basically before each of these tests, right? So again, we will need this private variable, the Boolean one, right? Passed. We have the same codes. We can copy it from the other tests. Again, absolutely the same code. And then again, we need to wrap the tests in the same try catch finally here in order to be able to catch what's going on. This is basically the the thing that we need to update the status and to update the exceptions. However, I want to show you one little problem that there is with the current solution without updating it. Let's rebuild the project. And I'm just going to filter by this class here and start running the tests. I'm going to delete the filter and create a new filter like this. As you can see, 22 tests, which is awesome. Now, let's start executing. Each test will start a new session, which is apparently okay. As you can see here, it was updated automatically for us, displaying that there is a new test. And the test started. However, let's see what's going on. One test is running, and this is awesome. However, you will notice that since this is, it will keep displaying with this particular name. Because right now, here for the name, I just provided this verified to-do list created successfully. And every time it will be displayed with the same test's name. However, this is data-driven test, and these tests were generated for us by xUnit. But unfortunately, we don't know here, we cannot say, at least in this particular moment, what is the name. However, I have a solution for you. And the solution is that through Lambda test, there is another command. And this command will allow us to update the name of our tests, which is really awesome. And I already have the snippet for that. And this is another JavaScript with providing the name, the Lambda / name equal, and then the name of the test that we want. Here, as you can notice, again, through string interpolation or a string format in the latest version of C#, we're basically simulating and generating the same name that xUnit is doing for us. Basically, this name here, mentioning the name of the parameter, 2 dots in the name of the technology. And now, if I rebuild again and run it again, you will notice that in a second, I'm going to run the same class, and I'm going to show you again the cloud here. There are already a few tests, as you can notice. As I said, they're with the same name, but we're going to wait a second, and you will see that it will be updated once the test is done. Just waiting a few seconds. It's really cool that live, you can see, as you can see, it was updated for us with the correct technology, which is awesome. I'm not going to wait for all of the tests, of course. Now, I want to show you another thing. We already looked how we can convert simple tests, right? However, I want to show you how, because in the last video, we already looked how we can run the tests in parallel, and we used these xUnit fixtures, right? To do so, in this third namespace folder, we developed this driver fixture. We basically use this base class here and created children classes for the different H drivers. We use the adapter design pattern for creating a factory method for directly initializing the proper browser and the driver for us. And we want to refactor this infrastructure to be able to run the test in the cloud, but based on this configuration here. This is usually how we do it in production in enterprise projects. Basically, in debug, when you run the test on your local machine, we test with real browsers. But when you basically run them in production, so to say, or in continuous integration, you can create another configuration with a proper test environment name, like QA or staging, or you can just use a release if you had just one test environment. For now, for simplicity, we're going to use debug for local environment and release for continuous integration or for your test environment. And when we run them in release, we want to run them in the Lambda test cloud. To do so, we're going to refactor the driver fixtures and the driver adapter to mitigate this. To be able to do that, we'll have to change this code here, right? But instead, I'm going to create a second version of driver adapter that basically will provide us the possibility to run them in the cloud, so that I can just show you the two versions. Later on, you can play as a homework to create a base class for them to reuse some of the logic. But for now, just to keep it simple, I'll create two separate implementations of the driver adapter. Now, I want, when I press Alt, I'm going to extract an interface for it. I will call it iDriver adapter. In C#, all the interfaces start with I, and I'm going to use all of the methods here. Also, we are going to add one additional method to the iDriver adapter for executing here, iDriver adapter, here it is. First, this will implement the iDisposable interface of its own. So I need to delete here the dispose. And then I'm going to add one more method to be able to wrap up these commands for extracting the cloud, to update the status, the name, and submitting the exceptions. This will be this command, execute script. And now we need to refactor a little bit the driver adapter. We need to implement the interface here. Basically, this will add the new method, execute script. And in order to do that, we need to cast a driver to iJavaScript executor and execute the script. This is it. Now, I'm going to create a second version of the driver adapter. We are going to call this Cloud Driver Adapter. In this Cloud Driver Adapter, we're going to move all of the initialization logic that we used in this first Selenium test. Basically, we're going to move this logic here. Let's see what will happen. First, we need to get the access keys here. Then it's a little bit tricky because I don't want to copy paste everywhere the initialization code. But as I said, if we copy directly the desired capabilities in this version, let's see what will happen. If I go to the desired capabilities, and if I go to just Selenium and copy these desired capabilities here, we need to add a using put. However, see that it's underlined, right? And see what is saying. It says that it's deprecated, it's obsolete, and we need to use the browser options classes. Right now, I'm using the stable version. I'm not using Selenium 4, but still, it's still complaining. It's totally buildable. You can run it like this. However, we'll keep using the new options version that it's using Selenium 4, right? However, as I said, the problem there is that we have different options classes for all of the browsers. In order to solve this problem, we're going to use a small trick. And this trick is that we're going to use the keyword dynamic. And dynamic means that basically every time we can initialize whatever here. It's not var, but basically it's running another .NET engine set simplified, another virtual machine. And right now, for each browser here, I'm going to initialize the proper Chrome browser option like this. And we have others for Edge, Safari, and so on. And this is working completely fine because we're using the keyword dynamic. You can check it in the MSDN. And then another thing that I did, we're just going to copy paste the code that I already showed you in the previous versions. This is completely okay, depending, since we're using dynamic, this is working just fine. For platform name, here we need to say Windows 10. And for test name, we need to change here a little bit the interface to provide string test name. And I'm going to use a C# default parameters. By default, this will be empty. And yeah, I'm going to use it, but I need to change this in the interface. So here I'm going to use name, test name, again, default parameter, and I need to update the another version as well. The simple here, the first version. Now, in the cloud driver adapter, we use right now, of course, we need to use the driver because we are not initializing it, the remote web driver. And what else? We are already, that's it. However, here, if the driver, I'm going to use the so-called EOVIS operator, or if this is no, it's not going to throw no reference exception. And this is it. However, we need to modify a little bit, actually, our driver fixture. This is the place where we initialize the driver. And in this implementation, we're going to change our implementation because, right now we're not going to use this different child classes. I'm going to delete them. In this third version, actually, we had to modify it to cloud, but anyway, you can download the code from before. And now we need a few more stuff. We will need one more thread local implementation, but for keeping the test name. Right now, we don't have a place where we initialize it. In a minute, I will show you how we can get the name. Also, I'm going to change here the property to work with the iDriver adapter. And also, we don't need anymore this protected field, and I'm not going to use this. We are going to use directly the driver fixture. And another thing that we are going to do is that right now, in order to initialize in the second part of the video, I'm going to show you at the end of the video how we can use proper JSON configuration files, how you can control how this is set up properly. But another option is basically to use preprocessor directives in C#, like this one. We can say, if this is the book, please compile this code, else if we're in a release, do something else, or otherwise throw argument exception that the environment is not supported. Why is this complaining? We need to change it like this. This will be our debug implementation. And for release, we're going to use, as you can see, this code won't be included in the source code if we are not in release, and vice versa. Here, I'm going to use the cloud driver. This is the power of these preprocessor directives. And if I change to release from here, you will see that right now this code will be included in the source code, which is awesome. This is how we can switch the versions. However, still we don't, we somewhere need to start the driver itself, because right now, basically I deleted, how we start the driver, and also how we initialize basically the, because I don't want right now everywhere to copy paste this code. I don't want everywhere to try catch these exceptions and pass the results. We need some kind of a extension to it. However, one way you can do it, where we start the browser, is that right now with the fixtures before, in this second version, if you recall, basically we are using the browser session and the driver session for the whole class. Basically, we're using the same session, and we're not closing the browser for every one of these data-driven tests when we run them in parallel. However, in order to be updated properly the tests in the cloud, we need to, as I said, we need to submit each time the test name and submitting the exception and the status, right? In order to be able to do that, we need to create a similar customization to, for example, the retry test case, the retry fact attribute. The problem here, of course, this is not a data-driven test, right? The fact, as you remember, this is just a single test. We need to find another way how we can, multiply this. But however, let's just copy paste this logic. Right now, I'm going to paste it here, and let's say that I will call this namespace runs, because I want to create a browser called, an attribute called browser run test case. Let's rename it to browser run attribute. And here we will have to replace and change the name everywhere. Browser run theory. In a second, we will have to figure out how this works. Browser run theory. This will be browser run test case. Again, we need to change the name here. And of course, we need to change runs. We need to change everywhere the namespaces so that they're not confused. And what else? Of course, this here we need to use the new browser run test case like this. We don't have any more of these retries, so we don't need them. In the browser run test case, we don't have these max retries. We don't need them, right? I don't need to supply them here in the constructor. Again, here the big problem is that actually this is supporting only, we're supporting here only one test case, one run, which is not the thing that we need. But we'll return in a second here. Also, we can use another logic. It's called before after test attribute. This is like another extensibility point. And I'm going to create this new class here. I'm going to call it browser attribute. This browser attribute we should mark it with public. And we need to extend the before after test attribute that comes from xUnit SDK or the xUnit software development kit. Here, we are going to use the browser type, and we need to create one property for it. This is how we're going to control what browser we're going to use, because we're not going to use anymore the child fixtures for each specific browser. So let's call this property browser. And by default, we're going to use Chrome. But since it's attributes, we need to provide this browser type from the attribute. And then we can override this before after test attribute. If we decompile it, you will see that we have two virtual methods, after and before. Basically, this is like a plugin for xUnit, where when you use this custom attribute, you can execute logic before the test and after the test. And we will use this to close the browser and start it again for each particular test if you use this logic right now. So I'm going to say public override before the test, right? Because we want to start a new session for each particular test. Before starting it, every time we're going to use the driver, static thread-local variable, which is unique for each particular parallel process of the runner. However, if it's not initialized yet, we're not going to close it. This is our safe statement. Again, remember, this question mark means that if the velo or the driver is not initialized, there won't be any exceptions if we call another method. So if we have a browser, we are going first to close it, and then we use the same driver velo, and here we are going to call our start factory methods. We're going to use the browser that we set in the browser attribute to start it, right? So I'm going to use the property browser that we set in the constructor of the attribute, and we can get the name of the test actually using this method info. This is using C# reflection. Through C# reflection, basically this gives us runtime information for the different types. And the method info is basically information about the test itself. So here we get the name of the test that we are running. And right now, we cannot use anymore the pages fixture in the current way we used to initialize them, because right now we basically, this is going to be called during the constructor of the tests, but at this point, we're not going to be able to initialize the driver because it's initialized actually after the constructor in this attribute before method. And this is why we'll have to change how our pages are working. I'm going to show you another variation of the page object pattern. And right now I'm going to make our pages static, meaning that I don't have to create a new object for each page every time, but instead we're going to inject the driver statically again, this property, in order to make it thread safe, we're going to use the thread local, and everywhere. What else? This is the main page. We can use it directly like this. I make all of the methods static, and we use the driver value. I need to do the same for the to-do up page. We need to use this static property for the iAdapter. And then everywhere I'm going to change all the methods to be static and to use the new static property. As you can see, right now we are using driver.velo. Velo is, if you recall, the thread local is just a special container in the context of multi-threading in C# that will give you the correct value for this particular process. We need to refactor the also our facade. If you recall the facade design pattern, here we use basically the whole workflow is described here. Right now, since our pages are static, I can mark the whole class static and the method itself as well. And instead of using main page like this, I can just use the like static, right? This is the name of the class, and that's it. Just we need to change the code a bit. Now, how we use the facade, it's even easier. We don't need anymore this pages fixture. Well, here for now, I'm just going to remove this code. And in our tests, we need to change them a bit. Now, we still need to use the driver fixture, because the driver fixture is the thing that will initialize the special thread local containers for each separate xUnit process. And we still need to initialize them like this. We no more need to initialize the pages because they are statically initialized. Actually, in a minute, we'll have to initialize them in our, we'll need to initialize them in the driver fixture. Not in the driver fixture, but in a second, just a second. Actually, in our browser attribute. We're going to do it in the browser attribute. We need here, because here is the place where we started the driver, the correct version of it. This is why we can get the static main page now. And they have this static thread local variable, right? And we can initialize it to the current driver fixture.driver. And we can do the same for the to-do up page driver. That's it. And if we return to the test, here we don't need this particular two fixtures. We just need to provide it here to the constructor. We need to remove it from here. And that's it. The to-do facade, since it's static, we use it like this. That's it. And now in the edge test case, we need to do the same. Driver fixture, we don't need the pages fixture. Actually, in the constructor, we just need the driver fixture, and we need to remove the pages fixture from here. That's it. And again, the facade, we use it as a static. And now, one more thing in order to make everything work. First, we need to set here which browser we want. In our case, this is our new browser attribute, right? Because we are no more saying which browser we want here in parallel. So we say the browser here. We can do the same like here. You can say Edge, Firefox, whatever. And after that, again, the problem here right now is that everything will work. However, if you recall the logic from our simple tests, we don't have this logic here, setting the status and the lambda exceptions, right? And saying which is the name of the test, like in our to-do test in the cloud. We need somehow to reuse this logic. However, our before test, it doesn't know the correct parameters, and this won't work. Even if we place it there, it will just get the particular name, and everywhere will have the same name. And as I said, we already copied some of the logic of the retry attribute. However, as I mentioned, if we return here to this test case, the problem here is that it's extending basically the this browser run attribute is extending the fact attributes. And let's go to the samples. Actually, I checked the whole documentation of xUnit, and actually there isn't a written documentation how you can do this. There isn't any articles or anything. Through many, debugging and everything sessions, I found only one example in their samples that it's relatively similar to what we need. And the thing that I notice here is that we have this fact attribute here, but also we have this Vɪᴅᴇᴏ attribute, and this is the thing that we need. And I noticed that this fact discoverer is changing how we discover the test cases, and we are selecting more than one. And actually, this is the logic that we need. I modified it a little bit, and let's see how we can make this work. Because if we look into the test case, it's a little bit different. Here, we are providing in the constructor the iTest case, xUnit test case interface. Again, these are some internals for xUnit that you don't need so much to understand. You can download the source code and see it for yourself. I played with it a couple of hours to make it work, but finally, I managed to have a working example to show you. And let's see how we can modify it and make everything work together. Now, first, if we go to our browser theory discoverer, you will see that we don't have this select, right? Which is a problem. And here is the whole source code. I will just spare some of the details. First, I need to enable here system link, but again, through this theory discoverer, which is again a totally different class, we're initializing many of the different test cases that we have for this particular test. And also, if you recall here the attribute is a little bit different. We first need to derive from theory attributes, and also we need to change here the name of the project, the name of the class of the discoverer, and also the name of the project here is parallel testing. We don't need any parameters here, so I will delete this. And the other difference, delayed message bus, I think this is the same thing. The other difference is in the browser run test case. Again, here you see how many, the constructor is totally different. It's we're not providing the xUnit test case, right? So I provided the clean body that we'll reuse. We'll just rename it later on, and we are going to add our custom logic. Now, we need to add using to xUnit, and I'm going to change the name, and we need to implement the interface, everything. Yeah, we need to apply here, change this here as well. And now, actually, in this run async is the place where this is the place where we run the tests, and after this, we can check basically whether the test passed or failed, and this is where we can check first through this test case that we provide there in the constructor. We have display name, and this is the correct name. After debugging, I figured out that basically this is the correct name that is generated for your theory tests. So we can use this particular code. We directly use the driver fixture for the particular thread. I'm using the third version, which is the modified for the cloud. Here we'll set the correct lambda name test. After that, we have this aggregator that we have here. It contains a method, a property that is Boolean, mentioning whether we have exceptions or not. And also in this summary result, we have this result property, and here we can check whether how many of the tests failed. So I'm going to write an if else and checking both of them, whether we have exceptions or whether in the summary result failed is different than 0. And then again, we'll have a different logic, because this code will run no matter whether you run your tests basically no matter where you run it in the cloud or not. This is why we need again these preprocessor directives, right? And if we are in a release, we're going to basically say whether the test failed. And if we're in the else, this means that our test is green, passed, so we're going to set to passed. Also, here through the aggregator, we can say to exception, get the exception message and the stack trace as well. This is our way how you can basically reuse all of it. And now, in order to use our new logic, we need here, instead of using the default TRA attribute, in order to use our new attribute, we need here to use the browser run TRA. This is our new, or how I call it. Okay, browser run. Maybe I can just rename it browser run TRA, because it's something like the TRAs that we need here. And this will use our new extension, which is really cool. We're going to reuse everything. As you can see, no more boilerplate code that you copy paste everywhere. We are using everything. And the last thing that I wanted to show you is how we can use JSON configuration files, something like this here. Basically, I want to create this particular JSON file. Again, we'll have different configuration based on whether we're on debug or release, or you can name it whatever configuration you want, staging or QA. We want to say here in the configuration whether we run the test in the cloud or not, what is the default browser version, and in arguments, we can provide all of the different configurations that we'll have, right? Whether it's console, network, timer, resolution, and everything. Now, how we can do that? First, you need a couple of NuGet packages. I'm going to show you. In .NET Core, you can directly double-click on the project. And this is the name of the NuGet packages. They come directly, this possibility comes directly from .NET Core. The packages are Microsoft extension configuration, and you need these two, JSON and binder. And now I'm going to show you what we need to do. First, I'm going to create a new package here called settings. And in this settings, I'm going to create a new settings class. And this settings class, I will mark it as public static. We will need to create a property to the root of the configuration. And we need using two Microsoft extension configurations. And this read-only private static field, we're going to generate this particular method. And I'm going to show you in a minute what we're going to do. First, we're going to get the current folder. We're going to get all of the files, and we get basically through this called get directory files, directory name, assembly, executing assembly. This is basically getting the location of our bin folder where we execute the tests. And this will return all of the files there. And we need to get the settings file, basically the settings file that if we name our file execution settings, if it contains the word execution settings and ends with JSON, we're going to return the first file. We will make sure that only file is copied in the bin folder, the correct one, whether it's debug or release. Then we use this configuration builder class that comes from .NET. And afterwards, basically, this library allows to convert sections of JSON and map them to C# objects, which later we're going to use in our code to create this branching logic. So here I'm checking whether we have a file or not. And through this builder, I'm saying add this JSON file here and reload if there's change. And then here I can say builder build, and this will return the whole configuration. Now, we need to create the so-called POC object. The POC object is basically an object containing only properties. Again, this is something that we're going to, it's a representation of, it's a representation of the properties that I showed you in the JSON. So we'll have this run in the cloud, which is Boolean, the default browser that it's string, the browser version, the platform name, and we'll have this list of dictionary of strings. Basically, this is a list of all of the options that have key and value. And how this works, basically, we'll expose a static method like this here, of this static utility class settings. And this root here, that it's read-only, it provides directly from .NET Core a method called getSection, that it's getting the section execution settings, and it's mapping all the properties. Will map them, initialize this class execution settings, and return it. This is how we will use it. And now it's time to build these JSON files. Let's add them to the project. Now, new item, JSON file, and again, I'm going to name this execution settings debug JSON. Dot JSON. I'm going to copy paste it. Of course, in debug, this option will be false, and we will have one more for the release. .release.json. Both of them, we need to copy them always to output, but I will show you a little bit of MS Build, how we are going to copy only one of them. When I open the project, you will notice here that these two statements were added. Right now, we're copying both of them. But as I said, we want to copy only the one that it's corresponding to the chosen configuration, all right? So I will delete one of them. And in MS Build, we have a variable called configuration that it's equal to the one that we set. And we get the variables through this $sign. In this way, we'll just copy the right one. And as I said, in our settings file, we're getting only the first one, which will be debug or release. And now, everywhere where we basically use in our cloud driver, I will create one more just to show you how we can utilize this settings file. I will name it settings adapter. and settings cloud driver adapter. Here it is. And now in this settings cloud driver adapter, we'll create two methods for initializing. First, we can get from the settings the execution platform name, all right, because we're setting it there. Also, we have the browser version. This is the way we use it. Again, we need to add a user to our settings, browser version, and again, browser version, which is really cool, right? And next, we need to create one method instead of having all of this, because we're already setting them, in the settings file. The way we can do it is to create this method. Let me show you. I'll just copy paste them to make it faster, and I'm going to explain. First, we're calling the initialize grid options from configuration. As you can see, again, we're providing dynamic because our settings are dynamic based on the switch. Then we're checking that we have any arguments in the list. If we have any arguments, we are iterating through this dictionary collection, and we're checking if we have a key and a value. We are adding this add additional capability to the option. The key is basically the key that we are initializing like this because it's a string. However, if you recall from the first cloud driver adapter, if it's a Boolean or a number, it needs to be integer, it needs to be Boolean, right? Otherwise, it won't work. This is why in the settings cloud provider, we have a second private method called format grid options, where we provide the string representation of the value. And then we have this simple branching logic where we check whether we can parse it or not. If we can parse it to Boolean, we just return the result, whether it's integer, double, or we return it as a string. We use this private method here. In this way, we don't need any more these options here, but we can configure them from our configuration. We can add as many capabilities as we want. We can change the resolution, the time zone, the networking, the console, the log name, and everything. You can configure it through the settings file, which is really awesome. As I said, to get started with running tests in the cloud is really simple. With xUnit, we had a little bit of work, but as you can see, just in a couple of minutes, we managed to do a really complex logic to be able to run the tests in parallel and everything. If we rebuild the project, also one more thing. Actually, we don't need this anymore. We don't need this anymore. Right now, you are fully capable to run the tests in parallel, these two, right? The compile to Chrome tests and all of that. Also, we can use our new settings logic into the driver fixture instead of into the driver fixture and into our custom theory extension. In the driver fixture, instead of using preprocessor directives, basically you can use a logic like this. A similar logic will be this one, right? You can use the same branching running the cloud in the theory attribute. You no more need this. You can use both approaches. The preprocessor directives are also good, but if you need something more, it's really easier. To spare time, I'm not going to run everything, but yeah, you are fully capable to run everything in parallel right now, which is really, really awesome in the cloud. Basically, you can in the premium accounts you can run in more than 2 threads, which is really awesome, especially if you have thousands of tests, right? So in next time, as I said, we're going to look into other Lambda test features, more advanced, like geolocation, responsive testing. We're going to talk about Selenium 4 and its different capabilities, how you can create different performance reports. It will be really awesome. Don't miss it. Subscribe to the channel. Also, if you have any questions, feel free to write to the support. Don't forget to check the awesome blog every week. They are really awesome and detailed articles. And also don't forget to get your Selenium certificate and test your skills. Thank you, and see you in the next video from our course. See you soon.